Hi, in this problem, we will compare the weights of a hollow shaft and a solid shaft based on certain conditions. And the conditions are the two shafts are of the same material, which means the density of the hollow shaft equal to the density of the solid shaft, and they are of the same length, which means the length of the solid shaft the length of the hollow shaft equal to the length of the solid shaft, and they are subjected to the same torque, which means the torque on the hollow shaft equal to the torque on the solid shaft. Also, it is given that for the hollow shafts, the ratio of the inner to outer diameter is given as 2/3, and we have to compare the weights. For comparing the weights, we will calculate the ratio of the weights, the weight of the hollow shaft by the weight of the solid shaft, and that is based on the condition that the maximum shear stress developed in each shaft is the same. So this is the summary of the problem. Now let's start solving it. So in the first step, we have to write everything down which is given in the question. So I have just written everything here in this page. Now we will start solving it based on this condition that the maximum shear stress developed in each of the shaft is the same. So we should have the equations for calculating the maximum shear stress. So we know that tau max equal to 16t by pi d cube. Let's take d as the diameter of the solid shaft. And for hollow shaft, tau max is 16t by pi do cube into 1 minus k raised to 4, where do is the outer diameter and di is the inner diameter of the this hollow shaft, and di by do is k. Now let's start equating these two, since the tau max is the same. So let's write 16 ts by pi d cube equal to 16 th by pi do cube into 1 minus k raised to 4. Here the 16 gets cancelled. Pi also ts equal to th. So what remains, we can rearrange it as do cube by d cube equal to 1 by 1 minus k raised to 4. And this value is 1 by 1 minus 2 by 3 whole raised to 4. When you calculate it, you will get a value of 1.246. So what in the first step we are doing is we are trying to find out the ratio of the diameters, which will be helpful to calculate the ratio of the weights. Okay. Now in the next step, let's find do by d. So do by d is the cube root of 1.246. That will give you 1.076. So the ratio of the diameters do by d, that is the outer diameter to the diameter of the solid shaft, is 1.076. Now let's go and calculate what is the ratio of weights, which is asked in the question. So weight comparison. For weight comparison, we are calculating WH, which is the weight of the hollow shaft, divided by the weight of the solid shaft, which is WS. We know that weight is mass into acceleration. So mh, which is the mass of the hollow shaft, multiplied by g divided by mass of the solid shaft into g. G and g would cancel, and the mass is density into volume. So this numerator becomes rho h, multiplied by volume, which is Vh, divided by, in the denominator for solid shaft, it is rho s multiplied by Vs. So material is the same, which means rho h and rho s is going to cancel out. Now volume is area into length. So the numerator is AH into length, and the denominator is AS into LS, where LS is the length of the solid shaft. Also the length is the same, which means this is also going to get cancelled. Essentially, the weight ratio is now the area ratio in this particular case. So let's write it down. This is equal to AH by AS. Now we have to find the areas of the solid and the hollow shaft to find the ratio of weights. So let's find what is AH. For the hollow shaft, the outer diameter is DO and the inner diameter is DI, and the cross-sectional area is the hatched region. Okay, and that area is pi DO raised to, pi DO square by 4 minus pi DI square by 4. Now we can take pi by 4 outside. Also we can take DO square also outside. What remains is 1 minus DI by DO square. This is pi by 4 DO square into 1 minus K square. So we have got the area of the hollow shaft, the cross-sectional area of the hollow shaft. Now the area of the solid shaft is, the cross-sectional area is pi by 4 D square for the solid shaft. Now we have got the area ratio. Now we have to divide AH by AS to get WH by WS. Let's do that. So the weight ratio WH by WS equal to area ratio AH by AS. This is now pi by 4 DO square into 1 minus K square divided by pi by 4 D square. Now this pi by 4 get cancelled, and what remains is DO by D whole square into 1 minus K square. We have already calculated the value of DO by D, which was 1.076, and we already know the value of K. Now let's substitute these two to get the weight ratio. So this is equal to 1.076, which is DO by D square multiplied by 1 minus 2 by 3 square. When you calculate this you'll get a value of 0.64. So the weight ratio, or the comparison of weights, we can quantify it as WH by WS equal to 0.64. Now to summarize, the weight ratio is 0.64, which means that the hollow shaft is only 64% of the weight of the solid shaft, while it is sustaining, both are sustaining the same maximum shear stress value. Okay, so that is it. Thank you for watching.